We might as well, I might as well start introducing what we're going to do today, and if any people will turn up in the next 5 minutes, they won't have missed a great deal. How many of you here have used the .NET framework before from either from APL or from other languages? Okay. So I guess you're new to .NET completely. You've no idea what it is.
Yeah.
Okay. I do have a little PowerPoint thing which just describes some stuff. So I will go through that. I wouldn't bother if everyone knew the stuff.
Does not .NET work in 10.1?
Yeah, it does. We work with the. I think 10.1 may have been the first version where we had. No, what happened is we had a 9.5. Which was essentially an interim release, which we called Dialog.net, but numerically I think it was 9.5. And then 10.0 was the first major version that was released with the .NET support in. What I'm essentially going to be doing today is going through a bunch of expressions in my session, so you'll see them come up on the screen behind. I'm not expecting you to, nor will you be able to, keep up with me and type your own stuff. So really this is a watch me while I investigate and experiment and look around to see what's going on. My system is set up with essentially it's scripted, so I'm just going to hit F12 repeatedly, and it's going to automatically put expressions into the session, which I will then execute. And if I remember what I do, I'll talk through them. As far as handouts are concerned, unfortunately, I'm sorry, there's very little. You're welcome to, at the end of the session, take away my session log file, which will have, all of my input and output and all the stuff that I've gone through, as long as I think I've increased the log size so that we are unlikely to, lose stuff as it falls off the top. Yeah, I've got an 8 meg log, which should be big enough for the sorts of things we're going to do. So essentially, I'm just going to be sitting here hitting F12, 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 and then we'll.
So it's that easy?
Yeah. However, I'll still get it wrong.
Is that script file something that we can use ourselves? Is that
you can, but it's. I'm quite happy to show you the script, and in fact, every year I say this. There's probably a presentation actually in. We could probably get 45 or 60 minutes of a presentation about how we do these presentations. What I've got is this thing called policy.demo.script, which just contains all of the lines that I'm going to do. But some of them have got, a leading ampersand in an expression is sort of a hint to the engine to say we're going to do something different with this line. So it's not quite a list of things one after the other that we're going to do. But you're welcome to have that. And I suppose maybe next year we should consider doing this is how we make F12 do different things each time we press it.
Is that when I make unreadable script?
No, I'm sorry?
Is that when I make an unreadable script?
Yeah. Well, it'll be also useful to distribute to other potential presenters.
Yes, of course, yeah. I mean, in fact, I wrote this originally just as a thing, and I think then Morton took it and generated a class from it, which makes it even more cool.
Right.
Anyway, so let me start off just with a little bit of silly PowerPoint, but just to go through. Now, I wish I had my pointer thing.
I appreciate the silly PowerPoint.
I mean, it's very silly PowerPoint. It's so silly it's not working. Hold on. Basically, what the PowerPoint tries to do is to just sort of set the scene before we actually start looking at any code. So there's no point in me telling you what's in it until I can show it to you, but it's not starting.
No, it's.
And now I'm going to get 3 of them. But,
Blame Bill Gates, it works for me.
I rather foolishly thought I'd use OpenOffice. Because it was a 100 meg download rather than a 1 gig thing. There we go. Yeah, here's my first suggestion for the improvement program. Don't expect me to ask the questions when I'm in a room full of, lots of people.
At least we're friendly. We're a friendly audience.
That's the thing. I mean, this session. I've done this session or things very much like it every year for the past 7 or 8 years. So I now have a very laid back, relaxed attitude to it, and I hope that you will as well. Feel free to interrupt, ask questions, suggest other directions that we could go in. I'm completely flexible. We can talk about really anything that you want.
Can we make jokes?
Sorry?
Can we make jokes?
Yes, and please do, because then I won't feel that I have to.
I guess that remains to be seen.
Yes, you can try and make jokes. Right, so let me just. Please. We're a bunch of people are just chatting about the stuff, and we're just going to see how it works. So. Okay, so typically when you have your Windows operating system, you get that, and these days the .NET framework is typically pre-installed on your machine when you get it. Now this slide is showing a listing of a directory called c/windows/microsoft.net/framework/v2 blah blah blah, and it's in that directory where all of the dynamic libraries that provide the implementation, all of the .NET stuff, they all reside in that library. And you can see here that there's 460 odd items in this directory. And essentially they're all dynamic libraries. For example, here there is a thing called system.web.dll. Now, inside that dynamic library are all the .NET, the code that implements all the .NET stuff to do webby things. There's another one called system.windows.forms.dll, which contains all of the code for Windows Forms. The reason why it's important to know what DLL's things are located in, and indeed that's in the Microsoft documentation, is that when we come to make use of this stuff from Dialog APL, we need to say, and this stuff, get some stuff from this dynamic library. Otherwise we're going to have to load everything in or search for things, and it's going to be time consuming. But the documentation says this class resides in such and such a DLL. So the system.web.services.dll, and we'll talk about web services later on in the presentation or in the workshop. mscorelib.dll is an interesting one because that contains all of the real primitive, the lowest of the low-level stuff that's in the .NET framework. That's the library that tells you what an int32 is. What you can do with a 32-bit integer and so on. So that's actually one of the first things we'll look at. That contains the simplest objects within the framework. So let's take a closer look at that assembly, mscorelib.dll. Again, let's talk about terminology. These things are implemented in dynamic link libraries, but the .NET documentation and the .NET code, to a certain extent, calls the contents of a dynamic link library an assembly. Okay, it's a collection of related things. So inside this assembly called mscorelib.dll, there are a number of namespaces. And they're sort of like namespaces that we have in Dialog APL. They're really just a sort of a grouping mechanism. In Dialog, they are a little bit more than that because there's in fact, when you're writing code, the presence of namespaces makes a difference. But in the .NET framework, really, it is purely just a naming convention. Okay, everything that's in the system namespace would have a name called system.something, but it really is just the name. It has no effect on how the thing actually works. And inside the system namespace, there's another namespace called IO, there's a namespace called text, and there's a namespace called... So there's a namespace called IO, there's a namespace called text, there are hundreds of other namespaces inside that thing. But in addition to these namespaces, there may be what we call in the .NET framework types, i.e. class definitions. Okay, throughout the afternoon I'm going to use the word class and type probably interchangeably because the .NET documentation does. When we talk about a class, we're talking about a type. An instance would be an instance of a class or an instance of a type. Let's look at what types are defined in mscorelib.dll. It tells us in there is something called int32, which we probably won't even bother looking at. There's not much interesting in 4-byte integers. There's a type called a string, which is distinct from a character array. Okay, the .NET framework has a character array, which has different properties and methods to a string type. And there's a type called date time, which is a useful type for manipulating, clearly, dates and times. And there are many more types in MS-calling.dll, too many for me to list through, or even be interested to tell you exactly how many there are. So we've got the IO namespace, the text namespace. Inside the IO namespace, there will also be a definition of types. For example, there would be something called file. So its full name would be system.io.file. Okay, and in the documentation, you'll see, system.io.file contains these things, or if you want to do such and such, use system.io.file. In the text namespace, there's a type called encoding. Okay, so that we can do text operations in UTF-8 encoding, or UCS16 or UTF-16, or any of those text encodings that we are becoming more familiar with now that we're entering into a Unicode world. Let's go back to that date time type. Okay, it has a number of methods, a number of functions within it that we can call to do useful things. It has a number of properties that return values to us and allow us to set values on a particular date time object. And there would be fields as well, which, for the purposes of what we're going to see initially, anyway, we can think of properties and fields just as being like variables. Okay, there's methods which are functions we can call, and then these two other things are essentially things that we can modify by assignment. So, for example, a method on a date time would be is leap year. Is this thing that we've got encapsulated in a datetime object, does it represent something that is within a leap year? There is a parse function which is very much like the APL execute primitive. Okay, given a string, process that string and return an entity. In APL, typically we'd give it a string that contained a numeric digit, and we'd get a numerical value there. ToString in the datetime is the reverse. Given an instance of a datetime object, it gives us a string representation, very much like the APL format primitive. So parse and ToString are inverses in the same way that we have Hydra and for. There are a number of properties on datetime objects. Now, for example, is a property that tells me what the time is, the date and time is, at the current moment, like quote_ts. Today will tell me what today's date is without any of the time information. Okay, and then a datetime clearly will have things like year, month, day, hour, minute, second, of course, and so on. Now, with the word briefly about the object-oriented nature of OO, how many people are familiar with OO programming outside of .NET anyway? Okay, so again, that's most of you. A different group, which was interesting. In an object-oriented system, what we deal with what we call inheritance, okay, or derivation, where we have a class which defines some functionality. Now, if we have a bunch of classes where a lot of the information, a lot of the implementation within can be common, we could. Let me give an example that would be better. If we were talking about, say, a class that defined operations on a cow, okay, and we had another class that was a pig, okay, it would make sense in an OO hierarchy to have a common class called animal, okay, that each of these got some implementation from. And then when we wrote our pig class, or when we wrote our horse class, we'd only need to write those bits that were different from our basic animal thing. So, for example, the animal thing would say number of legs, and it would return 4 perhaps. Okay, but for the other animals, we can change their behaviour for birds or for omnipod creatures. So the terminology we use is that we have, to follow that on, we have a cow, and its base class would be an animal. Okay, or we might have a cow that's base class is a mammal, and then the base class of the mammal would be animal, and so on and so forth. And in the .NET framework, this inheritance hierarchy cascades all the way down until right at the very bottom, everything in the .NET framework ultimately inherits from something called system.object, okay, which just gives you a nice little full stop at the end of the object tree. Once you get there, you know you've got to the bottom. And system.object also defines a number of methods and properties and fields and so on. So here's a picture of the MS calling assembly. It contains a number of namespaces. The namespaces can contain a number of types, and the types can contain a number of programmatic elements like methods and properties and fields. Which is what that picture is. Okay.
Could you go over the distinction between a property and a field? Because it seems to, is one you can set and the other you can't set?
No, I mean,
Or-
from a user's perspective, someone who is making the use of a class, essentially there's no difference. It's when one comes to implement a class where you make a distinction between a property and a field. A field is essentially just a variable. It's a slot, it's a location where you put a value and you can get the value out again. A property typically has some code that is involved that actually does the assignment, and has some code that is involved in retrieving the value. So, for example, what's a good thing?
So like now, okay.
Now, for
had to go
example, it has to
get-
go off and look at a clock to give you the
Okay.
value back. And now is another example where you can't assign to now. That doesn't make sense. So you may choose to implement that in a property. Properties typically have two functions associated with them. A function that we call a getter, which is called essentially to get the value, and a function called a setter that is used to set the value. And in many cases, we may choose to only implement the getter and not provide any code for a setter, and that would essentially give us something that was a read-only property, like now. Like in APL terms, called TS, okay, is a read-only variable. Rather,
Field is really data-ish.
really, yeah,
So-
you can have read-only fields, but but that's getting a little bit more bizarre. Really. That read-only fields tend to be used where you have something you just want to initialize it once, and then you know that it cannot subsequently be changed. Okay. I was going to say something else profound, but it's gone. Okay. So what we'll do. So what I wanted to do there is just give an overview of. You've got your computer, you've got the directory, you've got the DLLs, you've got the assemblies. Inside the assemblies, you've got your namespaces, and inside the namespaces, you've got your types, your class definition. Okay, so that was the PowerPoint. Let's come now to the APL. The APL, when it starts, you come up with a, do you want to participate in our customer improvement program? Right. So I'm going to just go through here, and I'm going to be pressing F12 repeatedly. I'm going to start off in a clear workspace, so you can see there's no pre-prepared stuff in this workspace. So we want to investigate this thing called system.datetime. Now, if I hit enter on this expression in the clear workspace, I'm going to get a value error. Okay? When you start a session of Dyalog APL, by default we don't load any .NET stuff in. You just get an APL session that works the same way that you've been used to for years. You don't automatically get any .NET functionality. If we wanted to call for example, the .now member of the system.datetime object to figure out what's going on, again, we get a value error. What we have, in order to enable the .NET features, we have a new system variable in Dyalog called quad using, which is analogous to the C#. If any of you use C#, they have a using statement. I think VB uses the word using as well to determine which bits of the .NET framework this application is interested in using. In a clear workspace, our quad using system variable is empty. We are using 0 parts of the .NET framework, so any time we try and reference something in the framework, we get a value. If I modify my quad using so that it contains the name of a .NET namespace, okay, I now have one element in quad using. So what the interpreter is now able to do is able to access things that are in that system namespace within the .NET framework. Specifically at this moment, all the interpreter has done is it's loaded the MS calling DLL, which is the one that contains the date-time definition and the definition for all of the lower level, the fairly primitive objects. So now we have access to the contents of that .NET assembly.
But where did it know to search for it? So all you typed in was just system.
Yeah,
Does it
my
have
question too.
Right. Okay.
path?
This is essentially a special case in the interpreter. If you, as soon as you initialize your quad user to anything, the interpreter knows that you're almost certainly going to want to use the contents of mscalling.dll. So we load that one automatically. That one we could find. Okay. In fact, system.windows.forms.dll, we sort of know where that is as well, but we're not going to load that one automatically because, it's not as likely that you're going to want to use that one just when you initialize your quad user. So essentially, the simplest setting of quad using just brings in that one dynamic library, and you can use the contents of that one thing. Okay.
And it knows to go to Microsoft.net.
Yeah.
Oh.
Okay. There will be cases we'll come to later where we load assemblies from different directories, and at that point we'll need to specify where the assembly is that we're going to use. We'll see that in an example later on. But now I can use datetime.now. Okay, the system now is just loading that DLL, so it takes a couple of seconds the first time around, and we now get something back. So what's happened here is the system has determined there's nothing called datetime in the workspace. It's looked at your current setting for quad using and said, there's a thing called system in here that I'm allowed to use. And it sort of said, okay, rather than looking for a thing called datetime on my workspace, I will now look for a thing called system.datetime in the .NET assemblies that I've loaded. And it finds something, it interrogates that, says, it's got a thing called now on it. So it will run that getter on that property and give us the result back. Okay. Something else we can do is datetime today. Just give me the date part of that thing. So when we do .now, we got the 16/9/2009, 26 minutes past 2. But we can also just ask you for today, and it doesn't bother giving us the time information back.
Now, what's the shape of datetime.now
Right.
is empty. What's a scalar?
It's a scalar. It's actually a reference at this point, so it's name class. In fact, and I think if I hit F12 now, not quite. So obviously, what's happened? I'll pick up that point just in 2 seconds.
Okay, sorry.
Datetime.now has returned something which the session has displayed. We can, of course, just assign that to a name, which I'll call lowercase now. And the name class of now is 9. Okay, so it's a scalar reference to an object. I guess everyone in the room at least uses Dyalog APL, so is familiar with namespaces in Dyalog and what I'm talking about when I talk about a namespace in the Dyalog context and something that's named class of 9. Okay. So the display form of this namespace is now. Okay. Now. Right, okay, that's fine. Ignore that. In fact, what I will do for the moment is I'll switch autocomplete off. Because that's going to get confusing. So now we've got this thing called now, which represents the time when I did the assignment. So when I did that datetime.now, it was 21 seconds past 14:28. So now we can look at some of those fields or the properties that are on this instance of this datetime object. We can extract, for example, just the year. What is the year represented by this instance of this datetime class? And of course it's 2009. And that has come back just as a number. Okay, the interpreter knows that that's come back as actually an instance of system.in32. The interpreter knows enough about that to return that as a scalar numerical value in the workspace. So we can add 1 to that. Next year would be 2010. Where if you like the 2001 Arthur C. Clarke movie, something beautiful is going to happen. Something wonderful happens in 2010. I'm looking forward to it.
I thought you should keep me if I fell asleep.
Right, okay, so in addition to see here, there is a month. You know, we can find out what month it currently is, and it's the 9th month. I mean, here all we've got is a ref, and we're doing a reference dot field in the same way that we do in namespace and in Dialog all the time.
Oh, because now is actually a reference to that
Now is a reference to
date time.
an instance of the date time object.
Okay.
And that instance has within it encapsulated the specific time when I ran that expression, which was...
And that's now, okay, and that's why it has all those properties.
Yeah,
Okay.
I mean, if I do that datetime.now again, it's now 14:30, but at the time when I ran that one and did the assignment, it was 14:28. So that point in time is encapsulated in that instance. And in fact, what I'll do in a couple of moments is I'll create different instances of the datetime object that correspond to different points in time, and we'll see what we can do with a number of instances. Okay.
Can you see the things that are available, the properties in
Right,
that thing?
yeah.
Like I just went into the Explorer and I can't see anything.
Right, now the Explorer doesn't drill down into these things, but Quad NC, no, not Quad NC, Quad NL can do. Yeah, exactly. So, for example, if I want to find out what all of the
Methods.
methods is probably a better one to go at the moment. I can do Quad L neg 3 on the
I didn't
thing.
get that.
Now, the neg 3 though, basically what the neg says is don't just look at the APL names that are in here, but drill down into the object hierarchy and give me all the names that you can find all the way down to system.object and give me all the methods. Okay, and in fact, I mean, I'll do that now, but there are 41 of them. Okay. Another little tweak that we've done here, when we extended the domain of Quad L to take negative integers, we took the opportunity then to return the result as a vector of vectors rather than as a matrix, which is why it's displayed in that form rather than as a matrix, which you would have been used to using Quad L on the positive integers. Okay, and some of these methods that we'll see here, we'll look into in a little more detail as we go through the examples.
You can't do autocomplete on that, so if I type
we can actually do, yeah, and the reason why I just switched autocomplete off was because this is still configured to autocomplete my previously entered lines in the session, which is what I showed you, Diane, yesterday. So if I type now, first of all, it's suggesting it wants to autocomplete with what I had previously typed into my session,
Right.
and I didn't want to have to explain that.
Yeah,
but if I do now.y, then it says...
It is, okay, but if you do date time dot, okay, because...
Well, let's just try datetime dot... yeah, it's interesting that's not... Okay, I'll
That's
check that out.
why I was wondering.
Yeah, I'll just make a note of that.
Remember
Well, because-
when you're typing just
Because it
date?
still doesn't know where date time is. There's no reference.
Well, yes, but it could go off and do that resolution through quad using, say, this is system.datetime, or what shared members has this got?
Yeah.
And then it could autocomplete on those at that point.
That would be nice
Actually,
just
there's something when you just wrote in date time, but was that the enhancement you made yesterday
I
about?
think it was. Those two expressions there are the expressions that I'd done earlier,
Okay.
which is why I switched it off, because I didn't want that point
Yeah,
to come
yeah.
up, but then the other point came up where we wanted the autocomplete, so I had to put it back on. And I can't disable that without going out and coming in again, and then we've lost the history of what we've done. Okay, so I mean, with those things like year, month, and day, they probably implemented as fields because there's very little programmatic element that is required in digging those things out. Okay, if we look at now.day of week, okay, that's going to tell me what day of the week today is, and it's clearly Wednesday. Okay, that is, I suspect, implemented as a property because that's probably gone off and had to do some calculation to figure out what the current day of the week is.
It's not a method?
I do not believe. Let's just try that. Because I suppose it would. That's right. Okay. I don't want to really get into the extension of the results of quantity, but the integral part of that is 2, which tells me it's either a property or a field.
Okay.
The dot 6, I think, was pretty sure is telling me that it is actually a property, not a field in this case.
Why don't you get this Wednesday from? Because I would have expected mine to say onsdag, but it says Wednesday as well.
Yeah, that's interesting. Because you're set up with a Danish system.
Yeah.
Well, it's because your computers in the US right
Take my mouse and have it.
So like this,
I
feel
don't
like your charger converter here.
Okay,
It's detected the 110 volts.
But if I hover my mouse over the time in the bottom right corner, it will say onsdag. So I would have expected that one to say onsdag.
Yeah, I mean, that's a good point. The reason for that, I'm sure, is that what this has returned is, again, an instance of a class, the name class of this. Oh, sorry, hold on. If I do wed gets, then the name class of wed is 9. So it's returned a reference. So it's returned an instance of a thing in the .NET framework. And I suspect that the display forms of that class is hard-coded as being the English days of the week.
Maybe there's a locale.
It's possible that there's a locale somewhere that you can say
there
that
is.
would translate that, but I haven't investigated that. And if there were a locale, I would have expected to have defaulted to your current locale anyway. So I'm sort of surprised that on your machine it didn't give you the Danish or
Could be
Wednesday.
the Vista version is an English version, but set it up as an Denmark, so it could be that it is remembering that.
It could be. I mean, the answer to the question is I don't know. I mean, the related question which nobody asks is, of course, is where this format for date comes from. Whether that comes from the locale.
Yeah, but that's different than mine had.
That is different on yours.
Yeah,
So that's
this is
coming
my
from the
local
local
one.
settings. Okay, so it's interesting that that is affected by your current locale, but the days of the week aren't. You can blame. When I say blame Bill, I of course refer to Bill Gates, since Microsoft has left it. Okay, so for example, because we've got this thing called now, which is a ref, we can do all the normal APL things. We can get the year, the month, the day of the week in a single expression, exactly as we would if now was a regular APL namespace that contained a number of variables. So we can get all of that stuff out, just like that. So let's look at this parse member of the date time class. What the parse member allows us to do is to give an arbitrary string to the datetime class and have it parse it and construct for us an instance of the datetime object. So if I execute that, that returns a datetime corresponding to New Year's Eve 2007. I didn't provide any time information in that string, so the time has been initialized to zeros. So if I run that expression again and assign it to a name called then, okay, that's its display form. It also, of course, is a thing in class 9. But now let's look at some of the methods that we can call on datetime objects. Let's take this thing that was New Year's Eve 2007 and add a single day to that datetime. Okay. And what actually happens here is that we actually get as returned a second instance of the datetime object. So it's not modified the one that we had that was called then. It's returned a completely separate one that corresponds to the 1st of January 2008. Okay. Then is unchanged. Then is still New Year's Eve, but the result of the add days would be New Year's Day. Let's take another example then. This expression takes quite a lot of explanation. What we've been calling so far is we've been calling methods. We've been calling datetime.something, datetime.parse, datetime.now, datetime. Okay, maybe there wasn't another one. Datetime.now, datetime.parse. If we actually want to create a, let me just phrase this correctly. The parse function is a nice way of a nice single way of creating an instance of the datetime class. Give me a string, give me a datetime. Okay, there are any other numbers of ways that it would be useful for us to create an instance of the datetime. For example, by specifying, as I'm doing here, a year, month and day as numerical values. Okay, or I might want to specify a year, month, day, an hour, a minute and a second as numerical values. Okay. An additional way that we've got of creating instances is, rather than calling a method that exists in the class to create an instance, you can use the APL system function called quadNew that basically says, create me a new instance of the class that follows, in this case the datetime class. Okay, and then give the information that I provide afterwards to that class, and it will do whatever it is defined to do with those numbers to generate an instance of the class. Okay, and we'll look at the documentation in a moment to see where the definition of what the datetime does with those 3 digits.
But does your argument have to fit exactly the argument that is provided by that?
Yeah. What will happen? I mean, maybe now's as good a time as any to look at that. If we go to the documentation. Now I wonder if I can do. No, I can't do that. So let me just go now to my Microsoft Developer Network documentation. Okay. And if you've got Visual Studio, or if you install the .NET SDK from Microsoft, which is a free download, then you'll have access to all of the Microsoft documentation for this .NET stuff. And if I do a look for system.datetime, okay, they actually refer to it as a structure in this documentation. We won't go into that in a moment. Okay. Now, what actually happens is, I'm moving around the place quite a lot. I've not given this presentation for a year, so I'm not quite as slick as I would like to be. What happens here is the interpreter says, create an instance of a datetime object, and then it looks in the datetime class definition for what we call a constructor function, a function which is defined as something that will initialize the newly created instance of the datetime object.
Okay.
And there may be no constructors, there may be one constructor, there may be several of them, but they will differ in the arguments that they expect. Okay, so if we look at this documentation here, we'll see that there are the public constructors for the datetime class. We follow that link, and there are actually several of them.
Okay.
And the one that we were going to call with those 3 integers that we gave was this one here that takes 3 integers, which initializes a new instance of the datetime structure for the specified year, month, and day. Okay, so what the interpreter essentially does is, we gave it a 3-element vector, 1965, 31A. It's gone through this list, identified which one of these versions of this function it can call, and then it calls into that function to initialize the datetime appropriately. As APL programmers, we're sort of not used to this, what we call overloading of a single function name. In APL, if we have a function that may take 2 arguments, 3 arguments, 4 arguments, 5 arguments, we define it once, and we may or may not look at the length of the arguments when it gets called. In a lot of the other languages, especially the compiled languages, there needs to be a distinct header for the function for each of the list of arguments that you expect. Okay, which is why we see different definitions of the same function. Okay. But the interpreter is clever enough to say, you've given me 3 integers here, I will therefore call this version of the function, which is documented as taking year, month and day as integral values. Okay. So when we run this expression in the interpreter, we now have a thing called JD, okay, which, as it turns out, corresponds to my date of birth. Okay. Now, again, because JD is a ref, it's essentially syntactically very much like a namespace in Dyalog API. We can strand 2 of these references together, my birthday and what the time was 10 minutes ago. And then for each of those, we can retrieve the day of the week, the day of the month of the year. This is just Dyalog API namespace reference syntax. So what this expression does is it returns those 4 elements for each of those elements of that two-element array. Okay, so it turns out I was born on a Tuesday. Tuesday's child is full of
Grace.
Really? A mistake has been made. Anyway, so that's so again that's
That's an
standard.
interesting word.
And new creates a new memory location? Is that
Yeah,
okay.
it creates. I mean, from an implementation point of view, what it does is it goes off to the .NET framework, initializes a instance of date time in the .NET managed heap, if that means it, in the
Yes.
memory that's associated with the .NET, and then we maintain a reference to that in the workspace. Yeah. Okay, and we can format. These are, if you remember, Tuesday and Wednesday were references, and the day, the month, and the year were all numbers. Okay, so we can format these up and display them inches and measures as well. Just now, it's just regular APL, from this point.
So you can use the properties and methods of visual, whatever this is, Visual Basic or whatever. It's still, you can still perform APL.
Absolutely,
Okay.
yeah, and it gets neater than that when we come to some of the other examples later.
So can you lift the bottom of the session?
Yeah. So in fact, let's do that now. A lot of the .NET classes provide implementations for comparison functions. They would call them comparison operators. As was pointed out yesterday, when we talk about operators, we do something completely different. The date time object implements a mechanism for comparing two date times. Okay, and it makes perfect sense for us to map some of our APL primitives onto those functions that are implemented in the framework. So, for example, I can say, was I born at a time earlier than 10 minutes ago? Clearly I was. Okay, significantly earlier than 10 minutes ago.
But it's a 1, 0 answer.
It's interesting, isn't it? No, my birthday, yeah. So, yeah, I was born before now, yeah. Sorry, excuse me.
You said considerably.
Oh, yeah.
And I said, but it
It's a
doesn't
very
that
big.
way.
It's a very big one.
But JD minus now doesn't mean.
It's JD minus now wouldn't, but now minus JD might. But we'll come to that actually. Let's just doodle around with these things a little bit more and look at these features. We added a day to New Year's Eve earlier on. If we add 45 years to the date that I was born, that will give me the date of my next birthday, which is clearly after today's date. My next birthday is at a time which is greater than where we are now. If I make a vector of my next birthday, my date of birth and today's date, okay, and we look at all of the times for those. So one's 2010, one's 1965, the other's 2009. What we can do is, because we've got these comparison operators that the .NET framework provides for us, we can apply the APL grade up function to this vector of date times and sort them into ascending date order. Okay. So there are a number of APL primitives that we can map onto functions within the .NET framework to do useful things for us. We talked about less than, and actually what the format does here is that goes up and calls that toString thing that I referred to before, which makes a call on the object to say, give me a string representation of yourself. Okay, we talked briefly about Quadernel just a few moments ago because the point came up. Here are all of the properties or fields that exist on the datetime object. Okay. And we talked about all of the methods that were on there as well, and a number of those we called. And I don't think I'm going to go into any more of those. But what we can do, because this is APL, we can assign our own variables into an existing namespace. So I can assign to a name called info inside this instance called JD, which just would tell me, obviously, that it tags that instance with the string, this is John's birthday. Okay. Now Quadernel 2 just returns those names that I've put into this thing. I mentioned before that when we use the negative integers as Quadernel, that makes us drill down into the .NET hierarchy. Okay, what we do with the positive numbers is just do what we've always done, which is just tell me what the APL developer has defined in that box. The negative numbers make us look, deeper down to see what else may be in there. Okay, we did that. And again, if we look at just those functions that begin with A, we can see the add days, the add years, and we can see that we can add seconds and all sorts of things as well. So if I add a year to my 45th birthday, which is next year, so my next birthday is in 2011. I mean, I'm just reiterating the things that we've done before. That expression returns a new instance of the date time. Again, a namespace reference, something with class 9. So, and we can combine all these expressions together. Birthday.addYears returns a reference which we can dot into to get the day of the week that will be, what day is my birthday on in 2011? And it's a Wednesday. Probably no surprise given that it's on a Tuesday, I think this year. So, okay, my 45th birthday is on Wednesday, my 46th birthday, lordy. Wednesday, 31st of August 2011. Let's go back to that parse function. If we try and parse something that clearly does not represent a date, it's worth exploring what happens in that case. And what happens is we get, we'll come back to that in a moment, we get an error. Okay, we're familiar with domain errors, syntax errors. What's actually been raised here is an exception. And we have an error number of 90 associated with this exception error. Now, an exception error is raised whenever we try and do something on the .NET framework and it errors. Okay. What happens is when we get an error of type exception, quad EN is set to 90, and we have a new system variable called quad exception, which contains information about what actually went wrong. Okay. Now, quad DM, for example, gives you information about what went wrong on an APL side. Okay, and quad EM gives you the error message associated with a particular error number. Okay, the quad exception is itself an instance of a .NET object. Okay, and as such, it has a number of members in it, and one of the members it has is a message. If we look at the message that's associated with the error that we just raised, what it tells me is the string was not recognised as a valid date time. There is an unknown word starting at index 0. So it's telling me that N in nonsense is where it failed to parse that string into a date time object. And there's other stuff in here as well. For example, the stack trace, it tells us where it was in its stack when the error was raised. The quad DM doesn't give stack information, does it, about where the error happened?
Right side.
Sorry?
Right side.
Yes, at that point you can use quad aside to find out where I currently am, but it doesn't necessarily tell you where I was when that error happened.
Right.
But quad exception.stack trace tells me exactly where we were within the .NET framework where the error happened. And in this case, it's not particularly interesting. We were in system.datetime.parse that called a function called datetime parse.parse for whatever reason the implementer decided, and that was the thing that generated the error. So when we do things that are wrong in the .NET framework, 9 times out of 10 we'll get an exception error, but we can use quad exception to determine exactly what happened. Now, let me not bang on.
Question on mine,
Yeah.
and I forget this all the time.
Yeah.
Okay, so mine, the first time I did it, I've been playing with the settings, and the box popped up, right?
Right,
There's a
right.
status.
Now I've got this box as well.
Yeah.
What happened here is that in addition to the exception error being raised in the session, the information that was encapsulated inside quad exception is displayed in our dialog status window. In the same way that if I type F quad WC an object type that doesn't exist, okay, I get a domain error in that case, but in the window I get some text that says invalid object thing.
Is there a way to turn
There's
that?
a way to turn it off. though.
Yeah. If you go
Like
to
you forget it.
options, or is it tools, if you uncheck auto status, okay, that will prevent that status window from popping up when errors occur. Okay. It doesn't do it. I mean, that status window doesn't pop up in runtime systems for obvious reasons. Okay, but in the development environment, it's pretty useful some of the time. you could look at that rather than having to type other expressions to see what you've done wrong. So I'll leave mine switched off because I don't think I'm going to rely on it anymore. So just to finish off with the date time object, there's a few other things we can do. We can say, is the year 2003 a leap year? Clearly it isn't. 2004, however, is a leap year. Okay. Year 0 is an exception. If we say, was year 0 an exception? A leap year, we get an error. And the message there is it tells us that date time objects only work for years that are between 1 and 9999, rather like line numbers did in Dialog API version 12.0.
We can't see BC.
I guess not. And in fact, year 0 I think never existed anyway. You went straight from 1 BC to 1 AD, so that would have been an error even in that case. Okay, so essentially that's one of the. It's not the simplest type we could have looked at, but it was probably the simplest type that had things that were worth exploring in there. We played around a little bit with the documentation that we have for the daytime. Specifically, we looked at all of the different constructors that were in there.
Yeah, how did you get to that again?
I started. Do you have Visual Studio?
I have Visual Studio,
Right.
but probably vanilla version.
Okay. Probably you can start Visual Studio and go to Help.
I have Visual Studio 2005.
We'll get to Visual Studio and documentation there.
Okay.
And then hopefully you'll be able to search for system.daytime. But the point that I was wanting to make, that rather cryptic commented out Workspace Explorer that popped up there, was a hint to me to go to our Workspace Explorer that we have in Dyalog. And if I go down to the metadata section on the bottom, I can right-click on this and do load. And what metadata is the term that we use to define the information that tells us what's in a particular assembly. Okay, by which I mean, let me give you an example. So I right-clicked on metadata to do a load. I then navigate to C:/Windows, Microsoft.NET, Framework, B2.0, that directory that I showed the listing for in the PowerPoint at the beginning. If I go there and I open the directory called, the assembly called mscorelib.dll, mscorelib.dll there, okay. What the Workspace Explorer allows me to do then is to navigate through the information contained within that assembly. Now, it doesn't do it in a particularly elegant way, but if you haven't got access to documentation or you haven't got access to other Microsoft tools, then this is better than nothing. So we can navigate through this, and every year I do this and I apologise. The tree structure that we have here on the left reflects exactly the internal structure of the metadata inside the assembly. We should tidy this up to make it less deep, and we should also make use of this pane on the right-hand side of the Workspace Explorer to display some of the information. But for example, if I carry on down this tree here, we eventually get to a leaf that's entitled namespaces. Okay, and in here we see the namespace system.io that I had on the PowerPoint. And also in here there is a thing called system.txt. Okay, but at the top there's this system namespace. If I open this leaf up, we can see that there are a number of classes in here, and one of these things is called system.datetime. If we open this up, we can see the list of constructors for the system.datetime object. So here we can see a definition of the constructor, which is abbreviated to CTOR, that contains the 3 integers. So we could use the Workspace Explorer not to get to the documentation, but to get to the structure of the assembly, to see what functions are in there. We'll see if we close constructors and go to methods, we can see that there are these things called add minutes, add months, add seconds, and so on. The same names that we return with Porter now. And the same names that we see when you look at the documentation. Okay.
I'm sorry, John, what was the root of that tree?
The root of that tree was the metadata leaf at the top. So you right-click on metadata, do load, and then navigate to the assembly that you're interested in.
Gotcha, thank you.
We don't load that information and read it all in
Because there's a lot of it.
because there's a lot of it, yeah.
Right.
Yeah. The other thing that we can do is if we've got Visual Studio installed, that comes with a tool called Daintree, which is a Microsoft program that can also be used to look at the contents of an assembly, and it does it in a nicer way than we do. Here, for example, this is Daintree open on that same assembly, and we can go to system.datetime down here, and it's got slightly more icons, but it gives us all the same information. Again, here we see all of those constructors. So we've seen that list now in several places: Workspace Explorer, this Microsoft tool, and of course in the documentation as well.
And how'd you get to them? Sorry, how'd you get to them?
There's a tool called Dyalog, which on my machine is installed in the program files directory. And you can start that on its own and then navigate to the file, or you can put the file on the command line like I've done there. And it then just starts and shows the contents of the assembly in the same way that the Workspace Explorer has done. And this is the tool that I tend to use of choice, because not only does this give me the list of names that are in there, if I go to that constructor we talked about before, you can double click on this and you can actually see the names of the variables, names of the parameters that it expects, and actually the code as well, the binary code that implements this function. Then it's not interesting to look to investigate down too much at this point. And what we'll see a little bit later on is we can actually extract that information directly in the session if we wanted to, because the way the APL works, all the calls that the interpreters are making to extract that metadata to see what's going on, we can do from the session as well. It's just more stuff in the .NET framework that we have access to. So let's. This is telling me that I need to look at JD again. Well, in fact, we're probably doing this now. So, JD, if we remember, is my date of birth. The .NET framework allows us to find, given an instance of an object, what type of thing is it. So the getType method tells me that JD is an instance of system.datetime. Okay? And of course that returns a reference, because it's returned a .NET object. Given that it's returned something that tells me information about system.datetime, I can then say, great, so given that this part of the expression returns system.datetime, I can make a call on a function called getConstructors, which will give me the, let's just assign it to a variable, they're all refs, and if we format those, that gives me exactly the same information that we saw everywhere else. I'm not doing this now to show you that this is a good way of finding out what your constructors are, because you should go to documentation and find out what each of these things means. The only reason I'm showing this now is that it indicates that there's no sort of boundaries from the APL's point of view about what you're allowed to look at and what you're not allowed to look at. As far as we're concerned, JD has got a function on it that tells you what type of thing it is, and from that you can interrogate it to find out what the constructors are. You could look at what type all the properties are and what the arguments are for all these functions and so on. It's just another way of illustrating that we can get into all the bits and pieces of the .NET framework from the APL session. Okay, let me just shoot through these expressions because I'm not entirely sure what it wants me to do any of those things. Right, okay. Here we've got a date time now where I'm going to call the constructor that takes 6 integer arguments. So I'm now providing time information as well. So that's given me my birthday at 3 seconds past 2 minutes past 1 o'clock in the morning. And what we're saying is, no, let me skip that for a moment because we're not going to get through to any of the interesting stuff. Okay, so let's just go back to, I think Brian made this point. We talked about comparing datetime objects, but we can actually subtract datetime objects. Okay. If you remember, we had a thing called now, which was what the time was at 28 minutes past 2. And we also have JD, which was by date of birth. If we subtract those two things and assign the result into something called diff, diff has a display form. Okay. We know that it's a ref.
Still an object.
It's still an object, but get type will tell me what type of object it is. And what it is, it's a thing called a time span. Okay, so we started off, we were just talking about date times, but one of the operations that we've done on the date times is return an instance of a different sort of object, namely an instance of this thing called time span. If we look at the properties that exist on this time span object, we can see that there are things like hours, minutes, seconds, stuff at the top, the days, hours, minutes, seconds, total seconds, a bunch of stuff. But if we look at days, that tells me that I've been alive for 16,087 days. I've enjoyed every single one of them, which is a little over 44 years. So we can do the arithmetic with .NET objects as long as they support, as long as they've said this is what you need to call if you want to subtract such and such a thing from them. So we've tried to bring in the .NET objects into the API language, where we can use the primitives as well. Okay, let's.
Johnny, can you scroll back up so we get the expression you used to get that list?
Yeah, sure. That was essentially. So what I did was I did three things. I subtracted two date times to get a thing called diff. Okay, and then essentially I just did diff colonel minus 2. What are the variables? What are the properties on this type of object?
And I could do the same thing if I call directly the property, right? In other words, if I did date time dot now minus JD, I could.
Yeah, let's just do that. That would be good. So date time dot now minus JD gives me the same stuff. I mean, I could do minus quad new date time. Not .NET. Well,
You get
well, I mean, because those will be. Well, no, quad not datetime.now minus datetime.now. Typically, it's all going to work too quickly. But we don't need to put these things in names first. We could do minus quad new date time. Well, what would be good was the 1st of the 1st, 2009, like the beginning of the year. Hold on. I've probably got those wrong way around. It's probably 2009.
Year first.
1-1. Yeah, okay. So this is the 258th day of the month, for example, day of the year, for example. So we don't need to put these things in names. We can just use these things as references. And there's some really neat expressions that you can write. We can do a lot of stuff. It runs the expression, gives you the result, and then everything just disappears. No names left in your workspace.
Now, if you subtract a date or today's date from your birthday, for instance, you'll get a negative.
Well, that's interesting. Let's just do that. Let's
play with that.
We did now minus JD, didn't we? That's that. JD minus now. Same thing.
But it's a low minus, so it's.
Well, that's
it's not any help.
Yeah, that's its display form.
Right.
Yeah. What we could probably do. I mean, we could probably do JD plus now minus JD will give me that back again.
Right.
So all of these things work, as you'd expect, I think. Well, I hope they work as you'd expect anyway. Right, so let's just move on a little bit. What I thought we'd do, because this is taking a little bit longer than I thought, which is no bad thing. We're scheduled to be in here from between 2 and 5. Okay, which is 3 hours, which we can certainly fill if you want to. I mean, I've got loads of stuff that we can talk about. What I suggest we do is we take a break for coffee at some point.
Yes.
We'll go on for a little bit longer. Once we get to 3:30, if we come to a break, any time close to 3:30, we'll take time to go get coffee for 15 or 20 minutes. and then we'll pick it up again. Okay.
John, I don't, how does it know the minus is it mapping into some kind of method, or is by typing minus to call a method in there?
What
happens?
What happens at this point is that if these arguments to minus were normal namespaces,
yes,
we'd get a domain error. Okay. So what the interpreter is doing is just prior to saying that's a domain error, saying, oh, hold on a second, these are .NET things. So it goes off to cache information about the .NET framework, say, okay, they're .NET things, but they do implement an implementation for subtraction. Okay, so essentially then we go off and just call that subtraction method, giving it the arguments.
So how do we know that is it by name, or does it have sort of a code that's subtraction? Because they could call it minus, or it could call it...
No, there is a specification. If we go back to that ILDASM thing, okay, which is Microsoft's tool. Okay, so here's the contents of the MS Call-It thing. If we go to system.datetime, okay, somewhere in here there is a function definition called op_subtraction. Okay, and if we look at that, and maybe if I double click on it, it'll be slightly easier. If we look at this definition here, which is in sort of a C-sharpy sort of language, what it tells us is that there is a thing, a special name. This isn't a normal function, this is a special sort of function. The op_subtraction tells us that this is the special function that does subtraction. And it takes two... Hold on a sec. Okay, I'm slightly confused. Maybe I'm looking at the wrong function, but because this is suggesting to me, as I read at the moment, that this allows us to subtract a time span from a date time. And that's because there's overloads, of course. If we go to this one underneath, here we go, this is better. Here we have a function called op_subtraction, which if we're able to if we look at this header, it takes a date time called D1 and a date time called D2. Those of you that are familiar with writing in C will be familiar with this type of function header. It takes a date time called D1 and a date time.D2, and it returns something called system.timespan, which is exactly what we saw when we did it from the API. So the interpreter has identified that in this date time class there is a special sort of function called op_subtraction, and that is the definition that says this is the one you can use to do subtractions, and we map that onto minus. There's similar things for on this class we can add things together. There's a equality function, a less than, etc. All those things that we mapped onto the API primitives. Okay, so let's just look at quad using again. What my quad using was set up to was just set up that it used the word system, and that meant that we could use datetime.now because the interpreter knew that it could prefix essentially the word system to datetime to find a full name that it could then get a reference from in the .NET framework. If I had typed system.datetime.now, I still get a value error because the interpreter is going through the elements in quad using and prepending that name to what I type. So in fact, in this case, it would be looking for system.system.datetime.now, which would give me the error. If I add an empty element to my using, so if I do quad using comma get end close quote quote, okay, we now have two elements in quad using. Okay, one of which is the 6-element system, and the other is the empty vector quote quote. But now, when I execute that expression, the interpreter goes through the elements of quad using in order, prepending to what I typed until it finds something that works. And because one of them is empty, that prepend operation is essentially a no-op. So my system.datetime now works. So the reason we put those names in quad using is that it allows us to abbreviate our expressions. Our API will become largely unreadable if it's listed with system dots on the front of everything, or system.io's on the front of
It
everything.
didn't override it, it didn't say basically refresh this. It said just append this into the, okay,
Yeah,
okay.
yeah.
So,
Yeah.
maybe I'm jumping ahead
Yeah.
and spiking if I am. But with quad using, on occasion it seems I need to append the location of the DLL as
Mhm.
well as the name of the namespace.
Yeah, and we'll come to that. If not now, we'll come to that
Okay.
shortly.
My only question is, how do I know when?
Right, you need to know when the only namespace, the only assembly that we load for free is MS Corley.
Okay.
Okay. Other assemblies that exist in that main directory, if you want to use those, you only need to specify the file name.
Okay.
Okay, and anything you want to use that resides anywhere else, you need to specify the full path name too. We'll come to examples of all of those later.
Okay, great.
Okay, but that answers your question
Yep.
right now.
So is this a little bit like quad path? So it's going to try the
Essentially,
first one,
it's like
then it's
quad
going to try
path,
the next
yeah.
one, but then doesn't that assume that there will be no overlap of, if I'm looking for something down here,
Yep.
okay, it better not have the same name as something.
It does assume that, and for that reason, quad using has actually got scope which allows you to localize it in a function. Okay, so if you are aware that you're going to have such a clash, you can either localize your quad using a separate namespace or make it just local for a specific function. So that you
Okay.
can temporarily alleviate those concerns.
Yeah, okay, that's sort of critical. Okay, so make it.
Like Quad IO, you could do exactly the same things with it that you do in Quad IO and not Quad Path because that behaves
No.
specially.
Yeah,
Yeah.
so that's why there's some analogies, but in here
It's more like
that's-
Quad IO
that's-
than anything else in terms
Yeah.
of where you can localize it and how you use it. Okay, so let's append another namespace to our quad using. Now I'm going to experiment with things that are in a namespace called Microsoft.win32, but still in that MS Corlib library. So now I have three elements in my quad using. Let's bring in the display function. So my quad using now looks like that. Okay, what I'm going to do now is I'm going to show you how we can use the .NET framework to interact with the Windows registry. Okay, which is something that we, up until now, we would be doing with Quad and A from Dialog
Yeah.
to access it.
See, here's
So
an
this is
example of one of the.
right.
I would rewrite.
So what I'm hoping to do here is to show you how much easier it is to get at that information with the .NET framework rather than with Quad and A to get to the low-level Windows APIs. So let's start regedit. Oh, excuse me. So what we're going to do, we're going to just use .NET Framework to look at the registry entries that are associated with the version of the interpreter that we're running. And we can see that in HKey current user /software/dialog /dialog API W1241 Unicode, we have a number of subsections and we have a number of string values that are displayed on the right hand side. I'm sure most of you have used regedit at one time or another to look at the Windows registry. So for example, what we do here is we're going to call the function called getValue. So rather than datetime.now or datetime.pars or datetime.isLeapyear, we're calling something called registry.getValue. We give it a string or a character array, which is the name of the registry section we want to look at. We give it the name of the registry value that we want it to retrieve. Okay, and then we give it another numeric value. This numeric value will be returned to us if this key doesn't exist.
Okay.
Okay, so in fact, I say integer. In fact, I think you can put anything you like in there, and it will come back to you if the thing didn't exist. Okay. So if we run that expression, we can see that I'm currently set up with approximately 128 meg maximums on this interpreter. Okay, so there's no quad and A. We haven't had to say, the get registry key takes a string and an int and stuff. We retrieved all that information. We know that. All we've done really is set quad using and then spend a certain amount of time looking at the documentation to find out what we're supposed to call it. But yeah, we should be used to that. If I try and ask for something that doesn't exist, for example, maximums 2, which isn't in the registry, then I get that -1 back, which was the value that I gave. I could do this and say, give me back the value, the string non-existent, and it would return that if the key isn't there. Okay. If I want to set a value, it's no surprise. Registry.setValue, the same key name Max was, and I'm going to set it to 32,000. Right, it's 32k. So we do that. Come back to my reg edit and hit. Let's just scroll down so that we can see where it was originally. There's my 128,000. If I hit F5 to refresh my registry, that changes to 32,000. There, we can see that we've made that change. Okay. What I'll do now is I'll just change it back to. Oh yeah, and of course the get tells us what we change it to. I'm just going to change it back to 128 now, otherwise what I do later on I won't. Okay. So it's that easy to use the registry now. All we need to do is to know what namespace the registry functions are located in, put that in quad using, and it just comes in out of the box, which is very much more convenient than it was before.
I have a question on overhead and how to do this. So right now, we have a bunch of registry functions, okay, that use quad and A, right? Okay, and I think how they do that is they may map and they'll do that quad and A once, okay, to create whatever it is, and then once it's there, okay, we don't have to worry about it again. Now, if I want to just leave the existing calls that I have and just replace these functions, if I localize quad using, okay, am I going to essentially take a hit because
there'll be a small hit, but it's not going to be loading dynamic libraries all the time. Okay. Because this stuff, once the library is loaded into the process, it's there.
It's there. Okay.
So you'll get a small hit because arguably this is a more complicated expression to parse. So you'll get a small hit there, but there's not going to be any chugging of the disk or loading additional libraries and stuff. Okay. Okay.
Got it. Thanks.
So that was looking at values in the registry. Let's just look at the other side of the registry editor and how we would get the contents of these guys out. Okay. For example, what I've got here is actually a slightly different expression, because this says in the registry for the current user open a particular subkey. So that means that I didn't need to type HQ current user in here. Okay. So it specifically says for the current users area in the registry, open the subkey for the Dialog APR 12.1 section. Okay. And we'll put that into and we will put that into a name called Dialog. And then from that we can say what are all of the names of all of the subkeys. And they come out as a vector of vectors, okay, which I just mixed. What quad ML do people tend to use? Three. Are you all three people? Because I'm a zero sort of person. Yeah.
I like the 0.
Yeah. Okay. Well, I'm not going to change now because the expressions that I've got in there on my script will start working if I change to 3. But I'm a 0 guy. I like my arrows to do inverse operations. So anyway, so that's giving me the names of the subkeys as a matrix. Anyway.
In your example up there, you used the current user, but could you have just used that same open subkey just with the set value with the...
The answer is, I don't know. Let's just have a look. The answer is, I don't know, and if I wanted to find out, I'd go to documentation. I mean, it's what we need is the open subkey is a member of the registry key thing. So, and what we did here is the answer is I don't know. Okay. We can take time out if you like to look afterwards and look into that.
During break.
Yeah, okay.
That's fine, thanks.
So there's all the value names. No, wait a minute, let's go back a step. That was, the first thing I had was subkey names, which returned the list of things that were on the left-hand side here. Then we had get value names, okay, which returns the list of all of the names that appear on this side of the, sorry, on the right-hand side of the registry editor. So if we wanted to get all of the values of all of the names out, it's a fairly straightforward APL expression, which gives me all of the values for all those names, and we can glue those up to get name value pairs in this section. Okay, it's just, I mean, you know, there's nothing there that isn't anything other than just, you know, a regular, fairly regular APL expression for each of the names, get its value, and then display the name and the value, and gets them all over in one shot. Not necessarily something you want to do, other than as a demonstration, perhaps. But that's what I'm doing. Okay.
Can you bring that back a second?
Yeah, sorry, that expression, that guy.
Yeah.
What I can do, if you like, as you leave, is I can give you my session log.
Okay.
And put it on your memory sticks, and that'll be what I've typed in and what came out, warts and all the errors, and all the things that I've done that I didn't want you to see.
No, it was the other one where you...
Oh, that one. Sorry, that's
Yeah.
the one that generates that two-column matrix. I take it everyone's familiar with defuns as well, the curly braces and stuff, and the alphas and omegas. Okay. Right, so I've got a few other silly examples of things. You know, what's the current version of my operating system? But I think, you know, you've got the idea of the sorts of things that we can do. What I wanted to look at was the file system, because something else that, you know, we haven't really got that's very nice in APL is a way of getting a directory listing, for example. So let's come to, look, there's a print there. That's a nice little underline mark, isn't it? Okay, so let's get display in again, set up some quad using. There's my quad using, and we're going to do that. If anyone's interested in what I'm skipping over, they can come ask me later. Yeah, we'll skip those.
Actually, in addition to your session, can you give us a script file?
I'll give you the script file as well, yes, of course. This is probably useful. Let's look at system.windows.forms. Okay, this is the Microsoft.NET way of generating a GUI application. Now, in Dyalog we use quite a bit of C, but this will show a few other bits and pieces of things that are actually useful. So I want to extend my quad using to use system.windows.forms. Okay, now the implementation of system.windows.forms actually doesn't reside inside mscalling.dll. So this is a case where I need to specify what DLL the interpreter should load to get this functionality. And the way we do that is in the element for quad using, we separate with a comma from the namespace name the assembly that we want to load. Okay, so from system.windows.forms.dll get system.windows.forms. So a bit of reuse of the names there, but one's the assembly name and the other's the name of the file.
And how do you know?
Documentation. Please.
Sorry I'm late.
Oh, you're welcome to...
I went to Morton a bit. Sorry about that.
That's all right. We're probably going to go for coffee in 10 minutes, so you can...
Oh,
and then we're going
I'm glad I'm not too late then.
You didn't want to miss that. Okay, so now we've got, in our quad using, we're saying we want to use some of the stuff that's in Windows.forms. Okay, now for the purposes of the next few lines of code, I'm going to operate in quad IO 0. Okay.
Just could you make a yeah, okay. So we know that's what happened.
Oh yeah, I mean it's going to turn up in that log anyway. So what I'm going to do is now I used quad new before to create a quad new datetime. I'm now going to create a new form. The constructor for the form doesn't take any arguments, so I can just do f get quad new form, and I get a new form. Okay, it's not currently visible. If I want to make it visible, I need to. Hold on. I need to set its visible property. So f.visible gets 1, and there's my Windows.forms form object. Okay. let's not worry about that. Okay, if I want to change the text that appears in its caption, I set its text property to Windows.forms, and you can see the top corner that has obviously changed. Now, the way that the Windows Forms GUI works is very different to how the Dialog GUI works. If I want to create buttons in this form, what I do is I first of all create a button, and then I add that button to the controls that appear on the form. So I do an f.controls.add, add the OK button to the controls on this form. Okay, and having done that, then we get a button that appears on the form. I can then obviously change its text. I can look at all of the properties that it has. It has 96 of them. One of them is top. Okay, so I can set its top to be 20, and it's operating on whatever coordinate system the .NET framework is using, which are these pixels. So that form is now 20 pixels down from the top of the form. There are a number of events on this button. Coordinate -8 returns all of the events that are on the object. There are 69 of them for this button. The ones that begin with C include an event called click. Okay. If I want to associate a callback function in APL with a click on that button, I do OK.onClick gets then the name of the function I want to call. Okay. So take the name of the event, prefix the word ON to it, and that's how you do the assignment of a callback handle.
Now this is all in the release that's about to come out.
Well, this presentation is largely unchanged from 12.0, so you've got this in 12.0 already if you have 12.0. And I think in 11.0 as well. Okay, there are a few things that we'll come to which are new in 12.1. There are a few things that are new in 12.0 that aren't in 11, but the on-click stuff and all of that is in 11.0 as well. Okay, so this is where I have to get. Oh, let me close that up. This is where I have to get quite clever with my script, because I've got a feeling that if I don't get this right, it's going to go wrong. So there's the. So there's what we're saying here is when we click on this button, call a function called foo. I'm going to define my function foo. Okay, and what it's going to do is it's going to take some arguments, and then it's going to error when the function gets called. So if we come out of this, and I come over to my form and hit the OK button, we get a suspension in the thing called foo. And we can look at those arguments, and what we see is arguments is a two-element vector. Okay. The first element is a reference to the button that's been clicked. Okay. And we can establish that by saying, if you remember, we did OK gets button.new. Okay, we did OK gets quad new button. Okay. And we can determine that it's the OK button that's been clicked by saying, does OK equal the first element of args? Oh. Okay, so that tells us that the button that was clicked is OK. We could look at its text, we could look at its position. The easiest thing to do is to say, using quality, is it this button?
It's not case sensitive. You don't need quotes.
You don't need quotes because these are references. OK, the name class of OK is 9. It's a reference compare, if you like, rather than comparing names over.
Now, if you did another button, not OK gets quad new button.
Yeah.
And set its on-click event to foo.
Yeah.
The reference that I see there is just system.windows.forms.button.
Right.
So there's no visual clue which button it is, but internally the reference is going to be different?
Yeah, I mean, there is a slight visual cue, because in fact it tells you it's a button, it also tells you what the text is in that.
Okay, yeah.
If I display args,
It's supposed to be 2 elements.
yeah, I was expecting that to be, well, let's format each of them. Okay, one of them,
okay.
you can see there that the OK is a clue which button we're talking about. Okay. And the other thing is something that tells us a little bit more precisely about what's happened. And so what we can do, for example, is within our callback function, we can set the text of the button that was pressed to be the word pressed. So if I do that, then we see at the corner that this button now has become pressed.
Right.
Okay, so we can get away without using names. We don't need to know necessarily that it was OK. We know that this is the callback for the OK button, so we can put in here whatever we want to do, and we can reference the button that was pressed directly without having to go through any of those names.
Right, but, you know, for instance, if I wanted to have kind of a central callback handler,
Right.
I need to kind of figure out what was doing what.
Yeah, you would need to use whatever mechanism you thought was best to determine which button was pressed. You could do it with an if it's the OK button, else if it's the cancel button. You might want to do a colon select on the text, for example, or something.
Right.
Whatever you
Would
felt
there
was
be a
best.
property or a field or anything with an ID, etc.?
That's interesting. Let's just do... Yeah, I've got a feeling. Is there a name on these things? Yeah, there is a name, so I suspect that. Let's just have a look. You could probably assign to that. Let's just see what name...
I think you set it on the button and then you would give it.
Yeah, and then you could do a select on button.name, for example.
Okay, yeah.
Yeah, so you've got a choice of things that you might choose to do. So we set the text to... Right, so the point again I'm making here is we set the text via first of args, but that clearly, because it's the same thing, has affected the text that OK returns. They're the same object. If we get the second thing that was passed to us, that's mouse event args, which contains a number of properties. It tells us, for example, what the X and Y coordinates of the mouse were when the user pressed on the button. Now, not useful in a button case, but if we clicked on a static field or something else, then we might be using that position for something. Yeah, or a picture, yeah, of course.
Now, is that relative to the object that was clicked or relative to...
That will be relative to the object that was clicked.
And so then you can take its X, Y, compare it to here.
Yeah, if you wanted to know where it was with it on the form, but
right.
yeah, that would do it. Okay. In fact, so if I just... No, it's not good. Never go off script, you'll be regretting it forever. Okay, so if we just let that function continue, let's see where we're at now. Okay, let's not look too much at that, that's not quite fun. Okay, so let's add another button to this form. Let's now add a cancel button. And we'll do, we're talking regular APL expression, we can assign to both visible, left and text in a single assignment. So that puts my cancel button up there. Let's talk a little bit about this thing called controls. What controls is, it's a collection, if you like. It's something that defines all of the controls that are on the form, and as such it has a field called count, which tells me that there are 2 controls on this form below. Okay. Controls is an instance of a thing called control collection. Okay, and we can look at the documentation for control collection and find out all the things that it does. But one of the things that it has is it has an item member, okay, which is a property. And because it's a property, in Dyalog we can use indexing on that property to extract the values. If you remember at the beginning I said properties and fields look a little bit like variables. So we're going to treat it like a variable. So get me each of the items that are in the controls collection. Okay. Now in fact, we can simplify this expression in a number of ways. In the .NET framework, an object has a concept of a default property, and that essentially means that if we have a reference, we can apply indexing directly to the collection without having to use the .item member as well. It's something that you see a lot in C#, and you see a lot in VB. Now, if I were a purist, I wouldn't allow it in APL. Okay, but there's a balance here between allowing an easy code path for people that have got VB examples or C# examples, and we're trying to get them into the API. So what we can do here is, rather than doing controls.item square bracket count, we can actually just apply the indexing directly to the controls collection. So this expression will take the 0th element in the collection and the 1th element in the collection and retrieve the text for each of those. So that will return pressed and cancel. Okay.
And it follows Because arrays in APL will start with 1, so
Using quad IO and 0.
Okay.
Right now, and this is another reason why this is why I changed my index origin to 0, because what happens here is that as far as the controls collection is concerned, we don't know what it thinks 0 is and what it thinks 1 is. Okay, they just happen to be the values that it uses to mean the elements that are in the collection. So the reason I changed my index origin to 0 was so that the numbers I put in there matched the result of IO to count earlier, for example. So these are values that mean something to the controls collection. They're not essentially indices strictly in an APL sense, okay? Which is why I changed my index origin. So my index origin was consistent with what the controls collection was going to expect. Okay. One of the examples, I don't know if it was in the another way of looking at this is there was a presentation by somebody, I forget whether it was today or yesterday, where he was actually indexing with a string constant. Okay, it was Chris Paul this morning, where he was talking about ASP.NET, where you have a session, which is the object that defines a connection between the client and the server in an ASP application, and he had session variables. Okay, and he was and session variables in ASP.NET are referenced by name. Okay, so I've done it now. So if he wanted to know the name of the user that was logged in, it was in full terms it would be session.item name. Get me the property that's called name and return its value. Okay, so the point here is that what you see within the square brackets is not an indexing expression. They are values that get passed to the getter for the property, and they have meaning at the other end. Okay. Right, now another thing, I said we could simplify that expression for a collection by removing the .item from that. Okay, in version 12.0 of Dyalog, we introduced squad indexing, which is very much like, rather than doing quad A 2, 3, 4, for example, okay, what I can do is I can do 2, 3, 4 quad A. I need to enclose that, which returns the same information. Okay, it gives you a more functional way of doing your indexing. Square brackets is syntax, and as such can get a little difficult sometimes. It's very difficult to programmatically create that array that you want to index by if you're using square brackets. But when one uses squad indexing, it's very easy to generate that left argument programmatically to extract what you want out of the array. Okay.
Where's the squad?
It's Control-Shift-L. Yeah?
Okay, that makes sense.
Okay, now monadic squad just returns the entire array. So when we apply monadic squad to the controls collection, it extracts all the elements from there and returns a vector of the controls that are in the form. Okay?
And if you didn't use the squad?
If you didn't use the squad, what controls is it just returns a reference to the collection. So what the squad does, it digs into the collection, extracts all the items and returns it to us as an array.
Sure.
So for example, those expressions are equivalent. That expression gives us the text for each of the buttons as well.
You're going to take a break?
Yeah, I just want to get to the end of this Windows Forms thing, and then we'll take coffee for 15 minutes. I think we're probably pretty much there. Oh, right, so let me just share this one other example here. So there's a number of useful controls. We've talked briefly about buttons. We could create a web browser control. We could add that to the controls on the form. We could, let's hide the OK and cancel buttons for the moment. We can change the URL of where this web browser is pointing and get it to point to dialog.com. I'll not get into that at the moment because there's actually 3 or 4 little steps we have to go through first. And it might be a good idea to get a coffee first. So let's take a break. I just need to figure out where I'm going next. So let's come back at 4 o'clock and we'll finish off for an hour with other bits and pieces. Yeah?